Good morning to all. In this particular lecture, we'll discuss about advancement in telecommunication network. If I'm talking about advancement in telecommunication network, that means I'm talking about advanced technology that are associated with the networking, as we have discussed in the previous lecture, like SONAT. SONAT is one of the advanced network technology of PDS, that is a piezo corner digital hierarchy. In the same way, we can conclude the things. Basically, if I'm talking about advancement in telecommunication network, that means we have different networking scheme, as like PSTN is there, that is a public switching network, public switching telephone network. Second one is ISDN, that is integrated service digital network. In the same way, we have ADSL technology, VDSL technology, and SONAT we have discussed in the previous lecture. So these are some of the advancement in telecommunication network, and which is, I think, very important, because if you are talking about advancement in telecommunication network, that means what we are doing, basically we are taking the reference of data rate and using all these technology, what we are doing, basically we are maintaining our signal in between source and destination. We are maintaining the data rate in between source and destination. So these are the important significance of this all these things. So first of all, if I'm as per your syllabus is concerned, the first thing is ISDN, that is integrated service digital network. And I think one of the important topic of unit number 5th, and which is very important for examination point of view. So basically, first of all, what is ISDN? ISDN is nothing but it is an integrated service digital network, and it's comprised of digital telephony and data transport services offered by the regional telephone carriers. ISDN involves the digitization of telephone network, which permits voice, data, text, graphic, music, video, and other source material to be transmitted over existing telephony wires. And basically, this is nothing but it is the whole representation of ISDN. It consists of different devices, like different connectivity, like we have TE1 devices, then we have NT1, NT2, NT1, then there is TE2 devices, then TA is there, then NT2, and this NT1. And this connectivity between TE1 and this NT2, it is known as S connectivity, or it is nothing but it is the reference point between terminal and NT2. And whereas T is nothing but it is a reference point between NT2 and NT1. Whereas this in the same way, we have this U interface. Is nothing but it is in between NT1 and ISDN switch. And now basically, what is this this NT1 is this TE1 is nothing but is a terminal equipment type 1, whereas terminal equipment type 2, and this is NT2, that is a network termination 2, network termination 1, and the TA is nothing but terminal adapter 1, or this NT2, same way, terminal network termination 2, network termination 1. So these are nothing but these are the device connectivity of ISDN, or this you can say it is a architecture of ISDN. Basically, if I am talking about this these devices, basically these devices, what this devices do, basically. So this particular part, this S interface, it provide connectivity between TE1 device and NT2. In the same way, this art provide connectivity between TE2 and terminal T and terminal adapter and so on. So basically So this is these are the important points as per the architecture of ISDN is concerned. So let's talk about the next point, that is different architecture devices, NT1, NT2, T1, NT1, NT. Sorry. This is NT1, NT2, ISDN devices, T1, T2, TA1, TA. So these things we have discussed in the previous slides. Basically, NT1 is connectivity in between what, NT2 is connectivity in between what, and this is termination equipment 1, termination equipment 2. This is especially for analog devices, and this is terminal adapter, and so on. So basically, this is okay. Now channeling, if I'm talking about of ISDN, basically we have two channeling here. One is a B channel, another one is D channel, and connection we have two connection. One is a BRI connection, that is a small connectivity, which signifies small connectivity, or BRI stand for basic rate. BRI stand for what? It stand for basic rate interface. BRI stand for basic rate interface, whereas this PRI, it stand for primary rate interface, and so on. So basically, if I am talking about the first part, that is the channeling scheme in B channeling, basically this B channel service, it operate at 64 kbps. It operate at 64 kbps and is meant to carry user data. It is meant to carry user data. Whereas D channel, if I am talking about, D channel services operate at 16 kbps. It operate at 16 kbps and is used, and is meant to carry control and signaling information. So this is these two are important point. Basically, 64 kbps correspond to B channel, and 16 kbps correspond to D channel, and so on. Whereas another important thing, that is a connection, that is a BRI. So BRI basically, what it do, BRI means, as I told you, BRI is the basic rate interface. The ISDN basic rate interface services offer two B channel and one D channel. BRI offer what? It offer two B channel and one D channel. So this is important thing, basically, key in ISDN BRI, it offered two B channel and one D channel, and this thing I've told you, B channel services operate at 64 kbps and D channel services operate at 16 kbps. So this is the important thing, basically. And this in the same way, this PRI basically, PRI basically, PRI service offer 23 B channel. It offer 23 B channel plus 1 D channel So this is important thing, basically. In case of BRI, it is 2 B channel, 1 D channel, and PRI it is 23 B channel and 1 D channel. So ISDN primary rate interface services offer 23 B channel and 1 D channel in North America and Japan, with bitrate of what? With bitrate of 1.544 Mbps, and so on. So this is the important thing. Now talk about the next technology, that is the SDR/DSL technology, that is a high data rate digital subscriber loop. High data rate digital subscriber loop. And these ADSL, that is ADSL that is the asynchronous digital subscriber loop, and VDSL, that is very high data, very high bit rate DSL. These are the nothing, these are the part of high data rate digital subscriber loop. So basically what we basically if this ADSL, if I'm talking about the first thing, that is the ADSL, if I'm talking about, so this is the ADSL DMT block diagram, means how exactly it work, what different part it consists of, and this is important thing. Because if you are concluding ADSL, so you must be aware of what different part it consists of and what is the significance of each block. So first of all there is a as the name suggests, as you can see here, the first is nothing but it is what it is source data, or you can say that it is also known as what, it is also known as PRS source. It is nothing but it is what, it is a pseudo random sequence generator which provides a prescribed sequence for characterizing the channel during a training period. Characteristic of the channel that are determined during the training periods are: first is attenuation and phase distortion across the band, second is noise interference level, and third information capacity of individual subchannel. Then another important thing is in between this FEC and source data, there is a channel allocation. There is CA, that is a channel allocation. What this channel allocation do, channel allocation, it is a provision of assignment of data bit to individual subchannel according to the subchannel capacity determination obtained during the training. Means it assigned data, what it do basically, it assign the data to the specific user and so on. Then there is a FEC. FEC, but it is a combination of what? FEC is nothing but it is a combination of Reed-Solomon code or convolution code. Means the coding scheme, that the coding we are doing, the coding which is possible here, it is possible using this FEC here. FEC. Then IFFT is nothing but is inverse fast Fourier transform, and what it do basically, conversion of data value to quadrature channel signal amplitudes and conversion to a time domain waveform using an inverse fast Fourier transform. So this is the important, means if you want a time domain conversion to the frequency domain conversion, then you have to use what, IFT sequence. Then it is what you do, DA, there is a digital to analog conversion here. Then filter basically we have transmitter filter here. This is a transmitter filter here. Basically what this transmitter filter do, it is a band pass filter. Actually it is a band pass filter used to prevent interference into the voice band and to smooth the discrete DSP samples. So this is an important thing. Then there is a port splitter. What it does, port splitter do, it is used to at both ends of the line to separate the analog voice from the data. Okay, but what it do basically, port splitter, it separate the analog voice data from the voice from the data. It separate the analog voice from the data. Then there is a AGC, that is automatic gain control, It is used to adjust overall receiver level. It is used to adjust overall receiver level. I think this part we have done in PLL, basically phased lock PLL, phased lock loop. So in that particular case, AGC is used to adjust the overall receiver level. Same thing here. Then there is the equalization, or you can say slope or decay equalization. It is a front end equalizer used to partially flatten the frequency response and equalize extreme delay variation in the channel. If there is a delay variation in the channel, then this thing can be equalized using this equalization. And A to D converter, further if you want analog to digital conversion, then it is only possible by what, it is only possible using this particular device. Then there is a FFT sequence here. Then there is a FFT. Basically FFT, what it do, basically fast Fourier transform. A reverse operation will take place here. Means in IFT what we are doing, basically we are converting time to frequency domain conversion. In the same here, basically in FFT sequence, FFT conversion of a time sampled waveform to the frequency domain where data value are related to the amplitude of quadrature carriers. So this is an important thing, basically. Then although there are other blocks also. Here we have what we have this block recovery is there, then frequency domain equalizer is there. Then this frequency domain equalizer, what this domain equalization do, what it do, basically multiplication of the complex frequency spectrum by amplitude and phase equalization parameters obtained during the training period. What you do, basically you can conclude the things ki it multiplication of complex frequency spectrum by the amplitude and the phase equalization parameter. Then there is a data detection is there, or you can say interleaving, slicing of quadrature amplitude values to decode data and subsequent generation of composite stream identical to original source data. So these are the parts of ADSL. That is ADSL, as I told you, ADSL means asymmetric digital subscriber loop, and digital subscriber loop which has the basic rate of 9 Mbps downstream, 64 kbps upstream, and it consists of what? It consists of PRS, FP, FEC, then IFT, then D2A. Filter part is there, then port splitter is there, and in receiver side we have AGC, equalization, A to D, and FFT sequence is there. Then there is a frequency domain, then there is data direction. So all the blocks has its own significance, and each block will perform its own operation. So this is the whole arrangement of this ADSL. And whereas if I'm talking about VDSL technology, that is very high bit rate DSL. So VDSL is nothing but it is a expanded version of VDSL. VDSL is nothing but it is expanded version of ADSL. It achieves higher bandwidth on short line terminals of fiber to curb systems. A primary motivation of VDSL is a potential distribution of SD TV signals among several proposed modulation techniques. DMT version is favorable. So VDSL is nothing but it is advanced version of advancement of ADSL technology. But in that particular case, what we are trying to achieve higher bandwidth, so that all the things, and that means data rate, inference parameter, we can work on that particular thing. So this is all about ADSL technology. So let's proceed further. Okay, now another thing is digital loop carrier system. Basically, the role of this digital loop carrier system, it is used to reduce or eliminate the copper pair from a central office to the group of subscriber vicinity. Means somehow what we are doing, basically we are reducing the complexity of our system. Using, if we are talking about digital loop carrier system, that means we are doing, basically we are reducing or eliminating the copper pairs, or you can say we are reducing the complexity of channel, because complexity or complexity of transmission media. So it is of two type. One is this UDLCS, that is universal digital loop. One is this UDLC, that is universal digital loop carrier system. Another one is the IDLC, that is integrated digital loop carrier system. The difference between these two we can conclude by this diagram, by this explanation. In the first case, that is this thing. In this UDLC system, first we have analog interface here. What this analog interface do? The interface between the local switching system of the public network and the central office terminal, COT. Central office terminal, that is COT. involves individual circuit, example individual analog tip and ring connection. Then there's a digital TDM. This particular thing is a digital TDM, the multiplex digital transmission link between the COT and RT, that is a remote. This is known as remote terminal. This is known as central office terminal. So digital TDM, basically digital TDM, the multiplex digital transmission link. It is a multiplexed digital transmission links between the COT and RT, and can be wired, pair or fiber. Means we can connect COT to RT by using some optical fiber, by using some copper cable, and so on. So then each interface of the COT is paired with a corresponding subscriber interface at RT. Therefore, the use of UDLC is transparent to both the switch and subscriber. The simplest mode of operation, the UDLC uses pure multiplexing between COT and RT. So there is one-to-one corresponding between the particular TDM channel and the COT or RT interface pair. So this is the arrangement of UDLC. But whereas if we talk about this IDLC, in IDLC basically there is no COT, there is no analog interface. So you can say here basically when UDLC system is interfaced with the digital system, certain inefficiency occur, and those inefficiency back-to-back multiplexing and demultiplexing, A to D or D to A conversion should be there. So this particular thing, listen now. So this particular thing, basically this particular part, it represent what it show an integrated digital loop carrier system, that is IDLC. It eliminates the efficiency by directly connecting the DLC TDM link to the digital matrix. Typically, direct digital connection are either DSL or even cross connect switches signals. Therefore, a fiber-based DLC system is interfaced with the switch through multiplexing, demultiplexing equipment as some number of digital cross connect signals. Functionally, carrier IDLC system was distributed switching system where some line interfaces of the switch are moved to remove the location. So we can conclude the thing basically ki in case of UDLC, in case of UDLC and IDLC, basically the main difference is that there is no analog interface, there is no multiplexing between COT and RT. So direct connectivity is there between central office to RT. So this is the important thing about this is the important difference between UDLC and IDLC. Talk about the next generation digital loop carrier system, that is this particular thing. The term next generation digital loop carrier system provide additional configuration option and interface. It is being adopted within the industry and is referred to the DLC system. And there are four basic attributes basically of this particular generation. First is optical fiber transmission capabilities, that is SONET and SDH we can use in this particular generation. Usually large line sizes and ability to interface with the central office operation support system for diagnostic, alarm and remote provision. So these are the important points basically that conclude next generation digital loop carrier system. And if we see here this particular diagram, most important feature of this generation system is the availability of new services such as copper or fiber digital subscriber interface in addition to conventional ports interface. Second is the most desired digital interface are T1, E1, primary rate and basic rate, Isdn, ADSL and VDSL. Another thing is other digital interface may also be provided for broadband data and digital video services. So these are some of the important conclusion of this generation, and which is I think very important if you are concluding or if you are talking about advancement in DLC technology. So let's proceed further. Okay, in the next is fiber in loop. Fiber in loop means what we are talking about basically. Fiber in loop is a, it is nothing but it is a system implementation or upgrading portion of the local loop with fiber optical technology from the central office of a telephonic areas to a remote location. Means what we are doing basically, we are advancing our transmission media by replacing it some optical fiber. So basically fiber in loop is a generic term and is used to refer one of the three more specific description of the use of fiber for local distribution. So we have what we have three category here. First one is the category 1, that is fiber to cabinet installed by local telephone companies. Second is CA2, that's category 2, fiber to curve, and in this case within 1000 feet of subscriber residents use ADSL technology. And category 3, that is fiber to home, that is FTH, home connectivity provide large bandwidth. So these are nothing but these are in this particular topic we are concluding what we are concluding the advancement in transmission media um, uh, with some optical communication, with some optical connectivity. So here in this particular diagram we are talking about hybrid fiber coaxial system. In here basically what we have, the cable TV system installed around the country can be acquired with downstream data transmission to subscribe by adding cable modem, upstream transmission from the subscriber to a cable TV head, and is much more difficult. Figure if we conclude this thing basically using this diagram. So basically using this diagram, so basically what we can conclude here, the coaxial cable portion of CATV system are configured as tree and branch topologies, with all customers receiving the same multiple channel broadcast signal. So means here what we are doing basically, we are connecting all these system via some optical fiber connection, and we have to connect all these system via this head end. Means we can't connect this particular, we can't connect this FN network to some FN network. So bidirectional amplifier is not here. That's why it is not. If bidirectional, you need what, you need some bidirectional amplifier here. If bidirectional amplifier is not here, so means bidirectional communication will not be take place here. So this is important thing basically. Then there is a voice band modem, that is a PCM modem. PCM modem basically, in PCM modem basically, or voice band modem basically, in early 1990, if I'm talking, voice band modem technology improved dramatically. It is becoming standard with ITO's recommendation. There are two primary factors of rapid advanced of voice band modem performance. First is the availability of economical DSP technology for eco cancelling. Second is the improved quality of network in terms of lower noise and distortion from the need all digital implementation. It is being identified that in all digital network, the only significant source of noise is the quantization noise of the analog to digital conversion. So in PCM basically, in this PCM modem, the major source of noise in the end-to-end connection is the quantization noise of A to D conversion. It leads to alternative modem implementation, which directly utilizes the digital 64 kbps channel and eliminate the quantization noise. These modem are commonly known as PCM modem. It relies on digital network to carry an unaltered digital signal from a digital source to a digital to analog conversion devices at an analog subscriber interface. This codec converts the PCM code word to a PAM sample that are detected by the receiving customer premises modem and converted back to the original PCM data. Successful data deduction requires the receiving circuitry to the adequate equalizer to combine distortion of D2A smoothing filters and the transmission linked to obtain quantization level of the codec and to become synchronized to the D2A conversion clock. So all these things I've explained to you means this is the internet service provider, then there is a D2A converter, digital analog conversion is a filter. I've told you that there is a this is the band pass filter to eliminate the interference and so on. So and then there is a equalization to settle down all the distortion. Then there is a PAM detection. So PAM detection is used to detect the signals and so on. So this is and all and detailed summary or detailed explanation I have given to in the lecture, so you can approach to that particular portion. So let's proceed further. Then there is a local microwave distribution. In local microwave distribution, if I'm talking about basically local microwave distribution, if I'm talking about basically, so this is the FCC has allocated two separate microwave frequency band for digital radio access communication services. The first one is multi-channel multi-point distribution services, and another one is LMDS, that is local microwave distribution services. MMDS is 2 gigahertz one way communication, whereas LMDS is nothing but it is about 28 gigahertz two-way communication. Basically MMDS, if I'm talking about, it operates at 2 gigahertz. MMDS is basically a wireless cable. MMDS is basically a wireless cable system, and it provides only one-way transmission. Reverse channel communication requires dial-up modem connection through the telephone network. But whereas if I'm talking about this local microwave distribution services, it operates at 28 gigahertz and provides cell-based two-way communication. Bandwidth available with LMDS are dependent on a particular services provider's frequency plan. Usually these plans provide bidirectional data rates of order of 1.5 to 15 Mbps, and total allocated bandwidth of almost 1 gigahertz can be partially to provide high data rate or asymmetric data rate is designed. So this is the important significance of LMDS and MMDS, and the basic disadvantage of LMDS are, the first thing is the basic disadvantage of LMDS are need for FCC licensing. Second is line of sight transmission, distance distance of limit of 2 to 3 miles, extreme attenuation is heavily rainfall. It is important thing basically. This is an important parameter basically. One, if we talk about microwave communication, and if we are working on high frequency, then rainy season is one of the disadvantage of this thing, because in rainy season your electrical energy convert into vibration energy, and vibration energy somehow distorted your signal. So this is the important thing. Then there is a potential interference from the other services like satellite in the same band, need of power in on the local subscriber sites, feed margin of or dynamic power control on the order of 40 dB overcome but the most served rainfall rate is. So this is an important conclusion of this technology, that is local micro distribution services. Means what are the advantage, what are the disadvantage, and other details you can go through your notes which I have already provided to you. So let's proceed further. Okay, thank you. Actually, if you have any queries, then you can drop me a mail, and you can ask me directly. Thank you.